Hey guys, this is Mr. Shell, and in this tutorial we're going to learn how to create a trend line, write an equation for that trend line, and then use your trend line to estimate data that you do not have. So first things first, let's review the parts of a good line graph. And this is not the graph from the previous tutorial. This is a graph that I made in Excel. I did that just because this is more clear. The grid lines are going to be a little bit better, and the points will be easier to see the trend line on. So remember, first you need a good title, and the title should be very descriptive. It should allow the person reading or looking at your graph to understand the graph without looking at anything else. So height of children measured yearly between ages 1 and 12. So now I understand what data or what information this graph is going to give me. And then I look at the axes titles. So down here we have age, and remember always to put your units when you're labeling your axes. So this is age in years. And once I put my units in the axis label, then I don't need to put it after every number. So I can just put 2, 4, 6, 8, 10, 12, and I don't need to put years after those. Next, look at the y-axis title here, and that's height, and we can see the units are in centimeters. So again, I don't need to write units after each of my numbers. When I'm labeling the scale there, I just need to label it once, centimeters, and then I know that all of these numbers are in centimeters. Okay, so what is a trend line? A trend line is kind of like the average of all the points that you have. So instead of, like we did last time, we just connected all of these dots together, a trend line kind of just takes the average of all of your data points. And this is useful when you have something like this, when maybe you measure a lot of different children, right? And this is, this is kind of the average of the height that they are at a specific age. And if we want to know generally what's the trend, so if I wanted to predict what a child might be at, say, age 6, instead of looking at this point, I would look at my trend line and say, okay, well, that's probably about where most of the children are falling, and this is kind of how fast they're growing. So drawing our trend line is actually quite easy. If you were doing this on paper, you would do it freehand. If you're doing it on the computer on Microsoft Paint, or if you're doing it in Microsoft Word, it's even easier. I'm just going to go up here and I'm going to click on draw a line. Actually, I'm going to make it a little smaller, but I'm going to draw a line here. And then you're just going to start down here at the bottom, and you can go back to the y-axis if you'd want. And then you're just going to stretch your line, and you're just going to try to make it like you're kind of shooting for the average of all those points, like right through the middle of all your points, and then extend it to the end of the graph there. And so there's our trend line, right? It's not necessarily going through any points. It ends up going through some of the points, but that's just how it happens to be. We're just kind of taking the average of all the points there, and we're drawing a straight line. One other thing I want to mention that I didn't point out was my scale down here, right? This is starting at 30 centimeters because the lowest point here was about 42, and so I don't need to go all the way down to 0 on my y-axis. Remember, we want to fill up most of the graph, or most of the grid with our graph. We don't need a bunch of blank space between 30 and 0 down there. So now that I have my trend line, a lot of times it will help to calculate the equation or create an equation for your trend line. And to do that, let me get the pen out here. To do that, all you need to do is pick two, and I would say 2 easy points on the trend line. And so I'm going to go with, let's say, and they don't have to be exact. And this is just going to be an estimate when you're doing it by hand. If you use Microsoft Excel or other programs, it will calculate the exact equation for the trend line. When you're doing it like this, it won't be exact, but it'll be pretty close. So if I look at like age 6 here, it's right on about 60 centimeters. And so I'll write out one of my data points here. Remember, y goes for x, your x coordinate goes first, so we're at 660. And then we need to pick another point, and let's see what's another good one here. Well, let's go 2 and that's right at about 45. And remember, I'm looking at the trend line. I'm not looking at my data points. I'm looking at the trend line. So 2 and then about 45. So 2, 45. There's my 2 data points. And remember, to get the slope of your graph, we need to calculate the slope first. The equation of a line is y equals mx plus b, and m being the slope, b being the y-intercept. And so we're going to calculate the slope first. And remember, slope, slope is the rise over the run, meaning when you need 2 data points, so how much the rise is how much the graph goes up, the y-coordinates, and run is how much the graph goes over horizontally, the x-coordinates. So rise will be y2 minus y1 over x2 minus x1. And you're going to take the data point to the farthest, or to the farthest right is going to be your second data point, right? Because that's what you'd run into first. I would run into, if I was doing my 245, I'd run into first. That's your x1, y1. And then if I go over 6 to 60, I run into that second, so that would be my x2, y2. So if I write that here, this would be x2, y2, x1, y1. So now I can just plug those numbers in. x2, or y2, 60 minus y1, 45, and then x2, 6 minus x1, 2. And so then if you calculate that, we get 3.75. So 3.75 is our slope. So we have m, and now we just need the y-intercept, and the y-intercept is really easy when we do our trend line, and that's why you extend your trend line all the way to the y-axis, because I can just look right here where the line is intercepting the y-axis, and that's my y-intercept. So it looks to be about, let's call it 38. So b equals 38. Now I have my equation. Y equals my slope, 3.75x plus 38. And there's my equation for my trend line, with my slope being right here, and then my y-intercept being right there at 38. And so then, this is really good, because now if you have a question or you want to know what a child's height would be at any certain age, you can just use your equation to predict that. So let's say a question asks us what might be, or what using your trend line, how would you predict the height of a child age? And you could say 5.5, right? That's not a data point that we have. I don't know how, I don't have a data point that gives me the answer to the height of a child at age 5.5, but using my equation here, I can just plug that in, right? X, remember x is age in years, so 5.5 plus 38, and then I could just calculate that. Let's see, 3.75 times 5.5 plus 38, and so it looks like that child might be 58.63 centimeters. And this is also good for predicting data that we haven't measured yet, or that kind of goes past what you've measured. So in our example here, if we want to know what the height of a child at age 14 might be, let's say age 14, and we just go up, and we see our trend line here is about 90. So even though we didn't necessarily measure the height of a child at age 14, we can predict that a child at age 14 might be about 90 centimeters. Now, just so you guys know, this is not real data. This is actually 90 centimeters for a 14-year-old is quite short. That's probably not the case, but this is just an example. And those are probably the two most common ways that you'll use a trend line, is plugging in an answer, a x-coordinate into the equation, or predicting data past what you've measured. I hope that helped.